Hello all, welcome to Mechanical Engineers Valley. So, in today's session, we are going to discuss next property, that is integral property of Laplace. So, integral property of Laplace, right? So, what we have to prove? If we have Laplace f of t is equal to a bar of s, then prove that Laplace of integration 0 to t f of t dt is equal to 1 upon s f bar of s, right? What we have given? We have given Laplace f of t is equal to f bar of s. Now what we have to prove? Laplace of integration 0 to t f of t dt is equal to 1 upon s f bar of s. Now, how we are going to prove this? Please give attention here. What we are going to do? We have to put phi of t is equal to integration 0 to t f of t dt. What I did, I have put phi t value for this entire term. Which term? This term, right? What I did, I have put phi of t for this entire term. Now, what I am going to do, I am going to differentiate both sides. So, what can I write? Phi dash of t is equal to d by dt integration 0 to t f of t dt, right? Now you know derivative and integration are opposite to each other, so they will get cancelled. So what I can get? F of t phi dash of t. So what we have received? We have received the value of phi dash of t is f of t. Now we have learned. Okay, before going ahead, what I am going to now. So let me mention equation 1. So I'm going to write when t is equal to 0, then equation 1 become what I will get? Phi of 0 will be 0, right? Now next step. In last to last session, we have discussed one property, that is property of Laplace based on derivative. So what is that property? Derivative property of Laplace. What is that property? Laplace of f dash of t is equal to s into f bar of s minus f of 0, right? Now what we did, we have assumed phi of t, right? So what, how we are going to write this equation in terms of phi of t? Now because we have used phi of t, right? So I'm going to write the same equation in phi of t. Laplace of f dash of t is equal to yes into f bar of will be written as phi bar of yes minus f of 0 will be phi of 0, right? Now what we have phi dash of t value, and we also have phi 0 value. So I'm going to put that value. What I will get Laplace of f of t is equal to s into phi bar of s minus 0. Now what we have given Laplace of f of t is equal to f bar of s, right? If you want to write the same equation in terms of phi, then how I can write Laplace of phi of t is equal to phi bar of s, right? Now I'm going to take this s on left hand side. So how I can write 1 upon s Laplace of f of t is equal to phi bar of s. Now 1 upon s Laplace of f of t is equal to phi bar s. I can write it as Laplace of phi of t, right? Now if you see here what we have assumed, we have put phi of t is equal to integration 0 to t f of t dt. So at the place of phi of t, I'm going to mention this term. Now what I will get Laplace of 0 to t f of t into dt is equal to 1 upon s Laplace of f of t, right? Now Laplace of f of t is equal to f bar of s. This is given to us. So at the place of f of t, I am going to mention f bar of s, right? So 1 upon s into f bar of s is equal to Laplace of 0 to t f of t into dt. So I am just rearranging this equation. I will take this term here and this term here. So Laplace of 0 integration 0 to t f of t dt dt is equal to 1 upon s f bar of s, and this was the outcome which we want to prove in this example. Sorry, right? So if you see the example, Laplace of integration 0 to t f of t dt is equal to 1 upon s f bar of s. The same term we have derived here. Now, if you have any doubts, you need any clarification, please comment me, and also please subscribe the channel, like the video. Thank you.